So, Assalamualaikum and hi, my name is Nur Hafizah Binti Salim. I'm from Process and Food Engineering Department of in UBM. So, today I will present to you about my FYP project titled Characterization of Self-Healing and Antifogging Properties of Gelatin-Based Films, which supervised by Dr. Hafizah Binti Bashar. So, this is basically the outline of this presentation. Okay, as per the introduction, gelatin is a high molecular weight polypeptide and an important hydrocolloid used in a wide range of food products, largely because of its unique gelling and thickening properties. Gelatin also has the excellent abilities to form strong, transparent gels and flexible films that are easily digested, soluble in hot water and capable of forming a positive binding action. So, as we can see in the figure, the transformation of red tilapia fish scale into whether freeze-dried gelatin that we extract from the pre-treatment and thermal denaturation process, or the gelatin powder, which we can buy it commercially, and we transform it to gelatin-based film and apply it to the food as a food packaging. Okay, next. So, what is the problem statement regarding this study? So, first, plastic packaging has limiting factors in which relatively poor performance under impact loading due to the lack of plastic deformation, in which we can see in the figure above. So, basically, self-healing materials are getting more attention to reduce fatigue and subsequent probability of failure. So next, the demand of longer shelf life and higher quality of food which mass transfer barriers to moisture, oxygen, carbon dioxide, lipid, flavour and aroma between food components and the surrounding atmosphere, in which gelatin can serve a good quality of mass transfer barrier that's suitable for certain foods such as vegetable. Next, the problem is the synthetic polymers as packaging materials has led to serious ecological problems in which they take hundreds of years to degrade, but not for gelatin. Gelatin is a biopolymer that takes a shorter time to degrade. Okay, what is the objective of this study? The objective for this study is to prepare and characterize of gelatin-based film, and then to study the self-healing and antifogging properties of gelatin-based film. So, okay, this is basically the method we use to study about this gelatin-based film, in which we extract the gelatin from the scale and transform it to gelatin film without additive and with additive, in which we will characterize it by mechanical test, thermogravitometric analysis, TGA, differential scanning calorimetry, DSC, self-healing test, and also antifogging test. So, next, this is the results of the mechanical properties. As we can see from the figure 1, based on the stress strain curve of gelatin-based film, we can see that tensile strength of the gelatin film without glycerol was determined to be approximately at 72 MPa, which is the blue line. And we can say that gelatin-based film that added with glycerol has a stronger tensile strength as compared to the gelatin film without glycerol, which you can see as the orange line. So, then this is the result for the TGA analysis. Okay, this is the decomposition temperature of gelatin-based film without glycerol is much more higher than gelatin film added with glycerol. And then next, this is the result for the SC analysis, in which we can see in table 2 that gelatin film without glycerol had high glass transition temperature and high melting temperature value as compared to gelatin film that added with glycerol. So we can say that incorporating plasticizer into the gelatin film significantly decreased TG and TM values of the films. So plasticizers reduce TG values due to the ability of the glycerol to penetrate between the polymer chains in order to weaken the interaction between the proteins. So, next, for the result of self-healing test, we can say that all types of gelatin-based film shows the self-healing behavior in which they were able to heal injury and can restore the film function. It is probably because of the new film segment that emerged between the gap due to the swelling of the damaged films and versatility of the polymer change under the stimulus of water, in which we can see in the figure 3 the self-healing process of gelatin-based film using biology microscope. Okay, next, result of anti-fogging test, in which we can also say that all type of gelatin-based film that we had studied, whether it is added with glycerol or not, shows no fog, while LLDPE film shows the fog behavior, which cover the appearance of the mushroom in the container with the fog that produced after we undergo the fogging test. It is probably because of the hydrophilic nature and water absorbing ability of the films. The water molecules in the condensed droplets is said to be quickly absorbed into the hydrophilic domains of the film by hydrogen bonds and dipole-dipole interaction. So it is clearly shown that the gelatin-based film plastic have good permeability to oxygen and carbon dioxide, water vapor and flavors for the fruits and vegetables. As we can see in the figure 4, the difference between the gelatin-based film and also the LLDPE films. Okay, so next, as per the conclusion, we can say that gelatin-based film, the added with glycerol has a stronger tensile strength as compared to the original gelatin-based film. The gelatin film that added with glycerol had good thermal stability compared to gelatin film without glycerol, as referred to the decomposition temperature and the incorporation of the weight loss of both type of film. And then gelatin film that added with glycerol have lower Tg and Tm value as compared to gelatin-based film that not added with glycerol. And then we can also conclude that gelatin-based film is a self-healing biopolymer that were able to heal injury and can restore the film function. Gelatin-based film has the anti-fogging properties, in which it has low oxygen and water vapor barrier that helps in maintain the freshness of the vegetables or food that being covered or coated with it. So as per recommendation, first, further research on the cross-linkers that can help in inducing the self-healing behavior of the film is also one of the recommended study. And then to acknowledge more type of gelatin rather than only one gelatin type, which is in this case red tilapia scale. And then further research on antimicrobial agents in which can be added value to the gelatin films. So that's all from my presentation. Thank you for watching.